Good morning to my dear students. So today we'll be seeing about the thermodynamics, the science of heat and energy, an introduction about this course thermodynamics. So we'll start from the basics. Now we'll define what is work and what is heat. So both work and heat, they are classified as one form of energy. What is the difference between work and heat? So work is nothing but the transfer of energy from one object to another, and it is mechanically defined as product of the force and the distance moved by the body in a particular direction in which the force is applied. Whereas energy, the heat is nothing but energy that is transferred between the objects due to their temperature difference. Due to their temperature difference, it flows from a warmer object to a cooler object until the thermal equilibrium is established. So work is nothing but transfer of energy from one object to another, and it is obtained by the product of the force applied into the distance moved by the object in the direction of application of the force. Whereas heat is the energy transfer between objects that have different temperatures, and naturally heat flows from a body at higher temperature to a body at lower temperature, and the heat flows from hot body to cold body until both bodies reach the same temperature. That is until the thermal equilibrium is being established. So what is first law of thermodynamics? So the first law of thermodynamics states that energy cannot be created or destroyed, only it can be transformed from one form to another. The next part we are going to see is about internal energy. So what is internal energy? Energy possessed by the system or energy possessed inside the system is called as
mobile or Wi-Fi connection first.
So the internal energy of a system is sum of the kinetic and potential energy of its particles. A system is made up of huge number of molecules. They are called as particles, and each particle they are in motion, and this motion of the particle creates intermolecular force of attraction, and due to which, yeah, kinetic energy is happen to accumulate in the particle. And by the virtue of its position, each particle also possesses the potential energy. The sum of the kinetic energy and potential energy of the particles is called as internal energy. And usually, normally, internal energy is expressed in terms of change in internal energy. That is, when there is a transfer of energy from the system, then you can note that there is a change in internal energy. So the change in internal energy is equal to energy transferred as heat plus the work done. That is internal energy U is equal to del E plus W. Del E plus W, that is the formula to calculate the internal energy. So what is the procedure to calculate internal energy? The change in internal energy is equal to the heat transfer plus work done. That is del U is equal to Q plus W. Now this del U, this change in internal energy is positive when the internal energy of the system increases. That is, when energy flows into the system, naturally the internal energy increases, so the change in internal energy becomes positive. Whereas when energy flows out of the system, naturally there is a decrease in internal energy and the change in internal energy is negative. And internal energy is measured in terms of joule, or it can also be expressed in kilojoules or megajoules also. And internal energy is a scalar quantity. Now we will see one or two examples. Now, scenario: a gas inside a cylinder. The gas is confined in a cylinder with a movable piston. The gas is heated, which causes it to expand and do work in the surroundings. 150 joules of work is done on the surroundings and 100 joules of heat is added. Now we have to determine what is the change in internal energy. What actually happens? The heat is added to the gas, increases the internal energy, which makes the gas to expand. So as the gas expands, it pushes against the piston, doing work on the surroundings. Doing work on the surroundings. So when gas is heated, it results in increase in internal energy. So this results in the expansion of the gas. The expansion of the gas pushes the piston upwards. So as the piston is pushed upwards, some work is done on the surroundings. Now, step 1, we calculate the work done, which is equal to 150 joules. The step 2 is calculate the heat transfer, that is 100 joules. So the change in internal energy is Q plus W, which is equal to 250 joules. So 250 joules of internal energy change has occurred due to this particular process. So conclusion. So understanding thermodynamics is essential in various fields such as engineering and physics to explain the energy use and energy conversion. And knowing about how energy is transferred and how to optimize systems, this will help us to better understand and improve the energy efficiency and save a lot amount of energy. So which is very crucial in today's world. So we'll see in the upcoming lecture series. Thank you.